Hello folks, and welcome. In today's lecture video, we're going to talk about percent yield, our last topic in this unit. It is covered under Unit 4, Standard 3D. So percent yield is a calculation. It is a way that chemists deal with the fact that the real world does not always match up exactly with what our math says should happen. So when you carry out a chemical reaction, you don't usually get all of the material that your stoichiometry says that you should. And so this percentage is kind of like a grade. In fact, I had a class in college where every week we went into the lab and carried out a process or procedure or reaction, and our grade for the lab was our percent yield. So calculating percent yield is the amount that you actually get, usually called the actual yield, divided by what you should have gotten, usually called the theoretical yield, and multiplied by 100. This is the same percent calculation that we have done previously, and that is done as your grades. It's just with the word yield attached to each of the components. So let's look at some example questions. In our first example, your stoichiometry says that you should have gotten 1.38 grams of copper, but you only measured 1.26 grams after the reaction was finished. And so the question here is, what percentage of the expected result? What was your percent yield? So again, the formula is actual over expected times 100. So we actually observed 1.26 grams. We were expected to get, we should have gotten 1.38 grams. So we divide, then multiply by 100. And so our percent yield in this situation would be 91.3%. This is a very high percent yield, right? This would be an A if this was your grade. Chemists in the field, right, in manufacturing, would be very pleased to get a 91% yield. In the second example, we did not do so well, right? So if the calculation says that you should get 7.8 grams of silver, but you actually measured 12.6 after the reaction was finished, we're asked to calculate our percent yield again. So we actually measured 12.6 grams. That's what we actually got. The calculation says that we should have gotten 7.8, so that's our expected value. You'll notice that this is a percentage that is greater than 100. This is not a good thing. This does not mean that you got an A++. What this means is something went wrong during the reaction, and your measurement is not just silver. Either you spilled something into your container while you were working, or something unexpected happened. Sometimes oxygen in the air can react with your product and cause problems, up to and including catching on fire or explosions. So if this had been a lab that I was doing in my college chemistry class, what they would have done is for every percent that you went over 100, you lost a percent on your grade. So this person would have had a 38 as their grade for the week because they went 62 percentage points over, so they would have lost 62% of their grade. You can have percent yields over 100. It is not a good thing. It is generally considered to be a very bad thing. So sometimes when you're looking at examples of this process and the calculations, you'll see that they are expecting you to do the stoichiometry and calculate your theoretical yield before you do the percent calculations. So in this example, we're told that we're reacting 21 grams of magnesium with hydrogen monochloride, and then we are told about our actual yield. And so in order to calculate the percent yield, we need to know our theoretical yield first. So we're going to take the amount of magnesium that we are provided with in the question. We're going to start our railroad tracks with that. We will go to the periodic table and look up the molar mass of magnesium. The grams of magnesium will need to go on the bottom to match on the diagonal. with the grams of magnesium we already have. Our next ratio will be the ratio between magnesium and magnesium chloride, the product that we are collecting. Since they both have understood coefficients of 1 in front of them in the reaction equation, that would be a 1-to-1 ratio. Our final ratio would be the molar mass of magnesium chloride. So we would go to the periodic table, we would add up 1 magnesium and 2 chlorines. In our calculator, we would multiply the numbers in the numerator, 21 and 95.21. We would also divide by the numbers in the denominator, 24.31. And we would get out of our calculator 82.246 grams of magnesium chloride. Since this is what the math, the stoichiometry, told us, this is going to be what we should have gotten, our theoretical yield. We would need to round that to match the significant figures of the number that we started with. 21 has 2 digits, so we would round our theoretical yield to 82 grams of magnesium chloride. So now that we have calculated the theoretical yield, the amount of magnesium chloride that we should have collected, we are now ready to compare it to our actual yield and determine our percentage. So again, we take the actual, which is given to us in the problem. You actually collect 75 grams of magnesium chloride. We take our expected, which is what the math or the stoichiometry told us we should have gotten, 82 grams. We divide, we multiply by 100, and in this case we got 91%, which, as I had discussed earlier, is a very good percentage yield. Generally, chemists in the field see something in the 80s. If you dip down into the 70s, that's okay, but people are starting to look at you suspiciously. And once you dip down into the 60%, people start asking real questions about how long you're going to work there. All right, so in this video, we talked about the calculation to find percent yield. We looked at 2 examples where you're given the actual and the theoretical yield, and all you have to do is the percentage calculations. And then we looked at 1 example of a compound problem where you had to do stoichiometry first to determine your theoretical yield, and then you could use the actual yield given in the question to determine the percentage. Thank you very much and have a nice day.